2.1 Properties of Radical Functions for Linear Functions. So we're going to start by doing a quick review of graphing a line and making an equation for a line. So in this equation, it's in y equals mx plus b, so this is my y-intercept, and then this is my rise and my run. So I would plot down at -3, that looks terrible. That's better. Okay, so at -3 I plot a line, or a dot, and then I go up 3, 1, 2, 3, over 2, and then I make a point. Up 3, over 2. Up 3, over 2. And then once you have 2 or more points, you can just connect them. So that's how you would graph that line. The domain would be x is an element of the real numbers, and the range would be the same. Alright, for this one, we're going to find the y-intercept, so it's at -1. And then we're just going to find the slope, so it looks like it's going down 1 over 1. So this would be y equals -x minus 1. So there's our equation. Domain, all the real numbers. Range, all the real numbers. Okay, so utilizing this information, we're going to graph radical functions for this. So what we're going to do is we're going to just graph the original y equals x plus 1, and then we're going to take the square root of that function. So if I plug in a -3, we would go -3 plus 1 is -2. -2 plus 1 is -1. -1 plus 1 is 0. -0.25 plus 1 is 0.75. 1, 1.25, 2, 3, 4, 5. So if I graph this, and I plot my y-intercept at 1, and then I go up 1 over 1, this would be my line. And I'm just going to plot all those points so it's easier for me to graph. So there is my line. Oops. Y equals x plus 1. So when we are square rooting, when we think about square rooting the answer, what I should know is that I can't square root a negative number. So if I try to square root this, I would get undefined. If I would try to square root this, I would get undefined. If I square root 0, I get 0. So this point stays the same. It's really nice because it just stays the same. And if I square root 1 as well, I get 1. And this point stays the same. So they're called invariant points because they don't change no matter what. Okay, if I square root 0.75, I get 0.866. So it gets a little bit higher. So from here to here, it goes slightly bigger. Oops, that doesn't look slightly bigger at all. Like that. If I square root 1.25, I get 1.18. If I square root 2, I get 1.414. Square root of 3 is 1.732. And this nice one that I want to focus on is the square root of 4, which is 2. So if I go to where it is 4, so that's at 3 and 4, this point's now going to be at 2. And I'm not going to worry about plotting all the other points. I'm just going to plot that one. So this looks like this. So I only focus on my invariant points, and that's square root of 4. So this line right here is the square root of x plus 1. So that's how you graph it. You graph the original line, and then you square root your y values to graph the square rooted line. So let's practice this again. For each of these graphs, graph the square root of it. Oh, wait. Go back to the last one. we need to do the domain and range of each. So domain for the first function is x such that x is an element of the real number. Range is y such that y is an element of the real number. For the square root of x plus 1, our domain is not all the real numbers. It's greater than or equal to our intercept, which is at -1 for all the real numbers. And our y's, y such that y has to be bigger than 0. It can't be negative. So this should be a pretty common theme. Okay, so let's do our original functions. The domain for f of x is all the real numbers. It can be everything because it's a line. Same with the range. And that's going to be the same for this one too, so I'm just going to skip that. Okay, so we're going to square root this and do our invariant points. So our invariant points are going to be the intercept and where y equals 1. So I'm going to plot that and I'm going to plot that. So our invariant points are at -2 and 0, and we don't really know what that point is. We'd have to estimate, but this one's important because it's our x-intercept. Okay, now what I'm going to do is I'm going to go over here where it's 4, and I'm going to square root it to 2. And I'm going to go over here where it's 9, and I'm going to square root it to 3, which is right here. So my graph is going to look like this. So this is the square root of f of x. So let's do our domain. So our domain, we know that it has to be bigger than or equal to -2. That's where that intercept becomes important. And the range is bigger than or equal to 0. Because that is all we can graph. We can also make an equation for this line quite easily. So it looks like our y-intercept is at 4, and it goes up 2 over 1. So the equation of this is 2x plus 4, which means that the equation of this is the square root of 2x plus 4. So it's pretty easy when we're doing lines. Okay, let's go do this one. So our invariant points, first of all, I don't want to use that color. Plot where it's the x-axis, our intercept, and where y equals 1. Then we're going to go over here where y equals 4 and square root it to 2. So that it's going to get bigger and then go through that point. And that's all I need to see for the sketch. So for the f of x, my domain, so this one is a little bit different because it's less than. So we want x to be less than or equal to 6. And our range is still bigger than 0. And we can make an equation for this line as well. So it looks like it has an intercept of 3, and maybe go down 1 over 2. So our equation for f of x is 1/2 x plus 3. So our equation for this green line right here is the square root of 1/2 x plus 3. Okay, graphing from an equation, we've already kind of done this, but you're just going to graph the original equation and then square root it. So we have an intercept at 4, so I'm going to plot my point at 4, and then I'm going to go up 1 over 1 for my slope. So I'm going to plot all these points to make it easier for me to find the intercept. But, however, we should be able to find the intercept on our own without the equation. 1 second. So there's our line. To find our intercept, we make y equal to 0. So we subtract 4 from both sides, so -4 equals x. This is important because it'll help us with our domain, but we do see it definitely quite clearly on that picture. So for f of x, our domain is x such that x is an element of the real numbers. Our range is the same thing. Okay, now we're going to square root it. So our invariant points are here, where x is at the intercept, and here, where y is 1. And then we'll go over here, where y is 4, and make it 2. So square root it. And then we'll go over here, where y is 9, and make it 3. So we'll go like that. And there is the function, the square root of x plus 4. Wow. There we go, that's better. So for this function, the domain is x is greater than or equal to -4. It's your x-intercept. And our range is y is greater than or equal to 0. And that is that function. Okay, let's do this one. Let's first find our y-intercept because, like, why not? It'll help us out. So you have 0 equals, that looks bad. 0 equals negative x plus 2. Subtract 2 from both sides. We get negative 2 equals negative x. I could have also just subtracted x. Divide both sides by -1, and we have 2 is equal to x. So we're going to plot this. Our intercept is at 2, and then we're going down 1 over 1. So a slope of 1, but going down. So your line should look like this. Okay, so for f of x, our domain is always the same, x such that x is an element of the real numbers when we're dealing with a line. Same thing. Okay, square rooting. So we're going to plot our intercept and our invariant point where y equals 1. Then we're going to go where it is equal to 4 and change it to 2. Oops, that's not right. I can't count. This one is 4. Alright, and then we can go over here to where it's 9 and make it 3. So like right here. There we go. And it's going to come, we need this 1 as well. So it's going to go up. Oh my gosh, I'm putting everything in the wrong spots. It's really hard to graph on the iPad. Okay, so it should look like this. So the domain for this is x such that x is an element. No, it's not. It's less than or equal to 2 for the real numbers. And the range is y is greater than or equal to 0 for all the real numbers. Alright, and that's how you graph the radical of a linear function. Next is quadratics.